Hey guys, welcome back. We're going to talk about balancing redox reactions. All right, so let's talk about this. All right, we have reduction. Right, and we're going to have oxidation. Reduction, we lose electrons, and oxidation, we gain electrons. All right, so a reduction is you have some metal or some compound, some element, right? Typically positive, doesn't have to be, but plus an electron or electrons, right? Going to the other metal or whatever thing. We'll make that about the same size here. Okay, there we go. And so whatever we have the charge, which is, right, minus electron here. So whatever number is here, it's this number, right, minus 1. Oxidation is the opposite. All right, oxidation, you have your element, and that's going to go over to your element, whatever your element is, plus an electron. All right, and so you're going to have your charge here, whatever this charge is here, the number of electrons, it could be 0, whatever, and it's going to be this plus 1. So you can go from -2 to -1. You can go from 0 to +1. You can go from +1 to +2. Right? But that's what oxidation is. That's what reduction is. All right? So when we balance these, we're going to have to balance these. Now, when we talk about reactions, there's half reactions. All right? These are half reactions. And the oxidation's a half reaction. The reduction's a half reaction. And so we're gonna balance each of those separately, then put them together. So let's talk about this a little bit here. So when we talk about balancing an equation, number one, first step is recognize the reaction is a redox reaction, right? That means what? It means electrons transferred. That means oxidation numbers change. Right? It's not proton transfer, electron transfer. Then we're going to separate into the two reactions, two half reactions. All right? And use net ionic equations. And then we're going to balance. So we separate into two half reactions and net ionic equations. We balance each half reaction for mass. So balance for mass first. Elements other than H and O. Then you balance O with H2O. And you balance H with H+. All right. Then we are going to balance the charge. Right? What does that mean? That means number electrons gained equals number electrons lost. Right? We can't gain or lose more electrons. So I can't lose 5 electrons and something gains 6 electrons. It doesn't work that way. Okay? The number of electrons have to match. Then we match the two half reactions and add. Then we cancel. All right? So then you match and add. Then we cancel anything. Then you cancel. And then we adjust for acidic or basic conditions. All right? Well, acidic conditions means we're allowed to have H plus floating around. And basic conditions, we're allowed to have OH minus floating around. But we're not allowed to have the opposite. All right, so if when you're acidic, you can't have hydroxide flowing around. It's going to react with water. Or it's going to react with H plus to make water. The basic conditions, right, you can't have H plus floating around. It's going to find out OH minus and make water. All right, so that's what we're adjusting. Now, a lot of times I will adjust at step 2. So for me, all right, sometimes I do these out of order. Sometimes I'll do step 7 at step 2 because I think it's easier. All right? It's just personal preference. It's less writing. So doing a few examples here. The oxidation, that's a key word right there. So chances are oxidation means that we're going to have electron transfer. I want a highlighter. So oxidation of iron 2 to iron 3. So iron 2 is going to iron 3 by dichromate, who is going to be reduced in acidic conditions, and the dichromate reduced to chromium 3. All right. So when we talk about oxidation, our oxidation is going to be what? Iron 2, Fe2 plus, and iron 3, Fe3 plus. Where's the plus electron at? Okay, that's the question. Well, we have 26 protons at both. Well, we have here, I have what? 24 electrons and 23 electrons. So I need my plus electron over there for my oxidation. All right, so we can always do that if we need it. All right. So there's the oxidation. Now dichromate's the reduction. So Cr2O7 2 minus plus some electrons are going to, that didn't work out for me, are going to Cr3 plus. All right. Well, now we get to start doing some of the fun adding. First thing I think we need to do is these oxidation states. Oxygen is minus 2. Chromium here is plus 3. All right, oxygen minus 2, so that's a minus 14 equals, wow. Hopefully you guys are screaming at the screen. That's much better, isn't it? So 14 equals negative 2. So that means this is a plus 12. So chromium is plus 6 there. All right. So what element is changing? Well, chromium is plus 6 to plus 3. All right. Now we got to balance for mass. Well, how many chromiums? I need to do what? I need to put a 2 here. So now my chromium's good. All right. So all the mass now is good except for oxygen. So how do I balance the oxygen? Add waters. 7H2O. Excellent. Now water's good. Oxygen's good. Hydrogen is now introduced. So now I have 14 H's. So we just put down 14H plus. And now we're good. Now we got the mass in. Now we have to balance the charge. Electrons. Plus 6 to plus 3. What's the change here? Well, each of them gain 3 electrons, don't they? And there's 2 chromiums, right? So that's 3 more electrons. So it looks like we need to have 6 electrons here. Which means, what do we have now? I have 6 here and 1 there. 6 and 1 don't work, do they? That means I need to multiply everything up top by 6. All right. Now, lastly, these acidic conditions. That means H plus is everywhere, right? I live by a Marine base, and if you live by any military base, and whatever branch, right? If I go, I don't go there much, but if I go to the Jacksonville Mall, a lot of young guys, if I just go up to most of them, I ask what unit you're with, they will give me a military unit. Oh, I'm with whatever. That's not true most of the places, right? But where I live, there's a lot of Marines. So there's a lot of Marines everywhere. Okay? You know, my daughter's soccer coach currently is a Marine. There's Marines. They're everywhere, which is great. No complaints, but they're here. Where I grew up on the street, there was like one veteran on my street. That's it. Of any branch, any services, right? And because only about 1% of the United States serves in the military or served in the military, and so I just happen to be in a very concentrated area of service members, which is wonderful. And so when you're in acidic conditions, you got H plus everywhere. Just like if you're in basic conditions, you got OH minus everywhere. So that means you can just throw in OH minuses if you're in basic conditions, or you can throw in H pluses if you're in acidic conditions, and it's fine, right? You're not like, well, how can I just? They're everywhere. They're acidic conditions. They're right. That's what's going on. All right, now we need to add these two equations up. All right, let's add up. I don't want to use pink. Well, I don't want to use pink. All right, so if we do this, I have 14 H pluses plus Cr2O7 minus plus 6 Fe2 plus the 6 electrons going to 2 Cr3 pluses plus 6 Fe3 plus 7 H2O plus 6 electrons. First thing we need to check, do those cancel? And I would say they do. So gone, gone. Does anything else cancel? No. So my net equation would then be what? 14 H plus in solution plus dichromate plus 6 iron 2s going to 2 chromium 3s plus 6 iron 3s plus 7 waters. Wow. Now, if I look at this problem, reading that, I am not going to come up with this. I don't think this is very difficult. I think you have to follow the process, if that makes sense. So it's not difficult. You just have to follow the process. Hopefully that makes sense to you. All right. So we're going to do a few more, and then hopefully that helps us. Balance the following reaction in basic solution. All right, that's important. So we're going to highlight this in basic solution. All right, and there's going to be a couple ways to do this. Now, first, I'm going to zoom way in. Oxidation states. What do we have here? O2 is 0. All right, so we got +1, -2. Hopefully you guys look at this and you know this is iron 2 hydroxide going to iron 3 hydroxide. So iron is changing and oxygen is changing. Which one's losing? Well, oxidation would be iron, right? FeOH2 plus an OH minus FeOH3 plus an electron. And it's only losing one electron, right? It's not losing any more electrons. And because we are basic, we can just throw that guy in, hydroxide in, that species, and we're good to go. Now, reduction. O2 plus some electrons is going to what? Oh, well, let's start doing a process. I got O2, well, we balance it with water, so that's 2 H2O. All right, Well, can't have that. Oh, no. We got to have 4 H pluses here. Can't have H pluses, can we? All right, we're in basic. So what I like to do, this is me, is I'm just going to add 4OH minus to both sides. This is how I adjust. All right, and then this, I just make 4H2O. But I don't change anything with it. I just leave it like that. Now we got to check our oxidation numbers. We're going from 0 to -2. Right? 0 to -2. And so each oxygen needs to gain 2 electrons. But there's 2 oxygens, so I think we got to have a 4 electron. All right. Which means we're going to have to multiply the top one by 4. All right, let's see if this works out. What do we have here? I have 4 FeOH2. 4 iron 2 hydroxide. Plus now 4 hydroxide. Plus 4 waters. Plus O2. Plus 4 electrons. And then on the other side, I'm going to have 4 iron 3 hydroxides. Plus 4 electrons. Plus 2 waters. And 4 hydroxides. Whew. Do our electrons cancel? 4 and 4. Yes. Does anything else cancel? Well, I think so. I got hydroxide and hydroxide. I think both hydroxides are gone. Then waters, we have 2 waters here, and I'm left with 2 waters there. I think that's it. Let's try it. 4 FeOH2 for iron 2 hydroxide plus 2 liquid waters plus O2 gas is going to give us 4 iron 3 hydroxides and that's it. There we go. Again, you got to follow the pattern. And there's lots of these to do and practice with. Number 3. We're at a balance equation for the reaction of manganese dioxide, or manganese 4 oxide, with hypochlorite to produce permanganate and chloride in basic solutions. All right, so let's write this out. I have MnO2 plus ClO minus yielding MnO4 minus plus Cl minus. All right, oxidation states. We have -1, oxygen's -2, oxygen's -2, oxygen's -2. All right, so we have manganese +4 here. Chlorine, and again, if we need to do this, if we need to go down and go -1, that's -2, so that would be +1. If you need to do that, please do that. And then we'd have manganese +7. We did that earlier in a different video. All right, so that's all our states. Oxidized and reduced. Well, we got 4 to 7. So if I go from +4 to +7, that would be oxidized. That's a change. And if we go from +1 to -1, that's gaining electrons. So our oxidation would be manganese 4 oxide, right, going to permanganate plus how many electrons? Well, it looks like they need to have 3 electrons. All right, let's balance. How's manganese? Manganese looks good. How's oxygen? Oxygen does not look good. I have 2 oxygens on the left, 4 on the right. So I have to add 2 waters. But that gives me 4 H pluses, which I'm just going to add 4 OH minuses to both sides. And this becomes 4H2O. I'm just going to leave it like that. All right, the reduction. Well, we have hypochlorite, ClO minus. Going to Cl minus. All right, and I forgot the electrons, so let's move this over a little bit. How many electrons do we have? Well, it looks like we go from +1 to -1. That's a 2 electron addition. Okay. Chloride's great. Oxygen's not great. We got to add water, which means we got to add 2H plus, which is 2OH minus. All right. So now we're balanced for mass. Charges overall. Well, we got 3 and we got 2. Top one looks like it's multiplied by 2, and the bottom one by 3. So now we have 6 electrons total. Let's try it. I would have 8 hydroxides plus 4 waters plus 2 manganese 4 oxides plus 3 times 2 is 6 waters plus 3 hypochlorites plus 6 electrons. And then we're going to have 2 permanganates plus 6 electrons plus 4 times 2 is 8 waters plus 3 chlorides plus 3 waters and 6 hydroxides. Oh boy. All right. Do our electrons work? Yes. Gone and gone. Waters. Well, hydroxides first. I have 8 hydroxides on the reactant side and 6 on the product side. So the 6 are gone. And this becomes 2. Waters. 4 and 6 is 10 on the reactant side. 8 and 3 is 11 on the product side. All right, and so gone, gone. One. All right, let's get the overall reaction here. We'd have 2 hydroxides plus 2 manganese 4 oxides plus 3 hypochlorites. Going to 2 permanganates plus 3 chlorides plus water. Whew! That's a lot. But again, it's a big process, but you have to follow the process. Alrighty. Last one. Oxidation of oxalate. That's huge. We know oxalate's going to be oxidized. All right? And so when we do this, C2O4 2 minus, Oxalate's oxidized, but only one of the elements is oxidized. That's kind of important. By permanganate, MnO4 minus, to produce manganese dioxide or manganese 4 oxide, we just did that one, and carbonate. Right, oxidation states. Well, we just did from last time. We'll carry it over. +7 and +4, right? Carbon. Carbon we have for oxalate. Oxygen's -2 and it's not changing. -2, -2, -2, and -2. And at this point, if you need to do this all out, right? So this is, it equals, I put a plus in. Hopefully you're screaming at the screen. Did it again. Hopefully by now you realize I can't talk and write at the same time. It doesn't work well for me. So this is -2. That's a -8. That means this is a +6. All right? So it means each carbon should be +3. On carbonate, we get up to -2. That's a -6. So that would be a +4. So carbon loses an electron. So in our oxidation, and now we're in basic solution, right? So for our oxidation, we have C2O4, 2 minus, got it right this time, going to, oh, didn't work, going to CO3, 2 minus, plus an electron. All right, balancing. 2 carbons, I need to put a 2 here. 2 carbons. 4 oxygens on the left, 6 on the right. Well, that's no good. We need to add some oxygens, 2 waters. Which then, 4H plus 4OH minus to give us our 4 waters. We're going to add 4OH minus over here. All right, electrons. We have carbon going from +3 to +4. So that's 1 electron. But there are 2 carbons. So that means 2 electrons overall. Reduction. We have MnO4 minus plus how many electrons going to MnO2. Well, the electrons we have +7 +4, so it looks like it's 3 electrons. Now we can balance for mass. Manganese is great. All right, however, oxygen's not. We need to add what? 2 more oxygens, so 2 waters. Which means I'm going to add 2, no, not 2, how about 4 H pluses? And 4 OH minuses to both sides. And this is just 4H2O. All right, I like it. Does 2 equal 3? No. All right, so the top one gets multiplied by 3. The bottom one gets multiplied by 2. All right, let's do some adding here. Hopefully that's straight. All right, 3 times 4 is 12. OH minus. Plus 3 times 2 is 6. H2O. Plus 3. Oxalate. C2O4 2 minus. Plus 8 more waters. Plus 2 permanganates. Plus 6 electrons. Woo! On the bottom, 3 times 2, 6. CO3 2 minuses. Plus 3 times 2 is 6 electrons, plus 4 times 3, 12 H2O, plus 2 times 1 is 2 manganese 4 oxides, plus 4 more waters, plus 8 hydroxides. Holy cow. There we go. Now, looks like 6 and 6 cancel. That's good. Hydroxides, on the reactant side, we have 12. That's it, 12. On the product side, we have 8. So the 8's gone. And this becomes a 4. Waters, we have 6 and 8, which is what, 14? And 12 and 4 is 16. So the 6 is gone. The 8's are gone. I'm going to get rid of the 12 and make that a 2. Now we're going to add them up. Let's see what we get. We have 4 hydroxide plus 3 oxalates plus 2 permanganates going to 6 carbonates plus 2 manganese 4 oxides plus 2 liquid waters. And that's it. And so that's balancing. It's tedious, it's long, but it's good. Now, if you look at this one, this reduction, it should be almost the mirror image of this oxidation right here. All right? And that's foreshadowing for what's coming up, right? The oxidation reduction, like the reactions are flippable, kind of. All right? So that is balancing redox equations. If you have any questions, reach out to me. Otherwise, we'll see you next time. Take care, guys.